I work at the Faculty of Engineering at the University of Alberta. I'm here with the Associate Dean Research and Operations, Professor P.Eng. We're going to talk about today a little bit, well, he's going to present us about the U of A, as we call, University of Alberta, the College of Natural Sciences, Natural and Applied Sciences. And we're gonna, he's also gonna let us know about the seed funding program that we actually is launching today for all of you, so you're aware of the different activities we can carry out in these 3 upcoming years. I'm based in Lima, Peru, so I'm going to be here supporting UTEC-UAlberta activities. So if you, after this presentation, have any question or need more information, I'm going to be here every Tuesday and Thursday from 9 a.m. until 4 p.m. But I'm based in Lima, so feel free to send me an email. So Professor MUSILEK, he is the Associate Dean of Research and Operations at the faculty level, the Faculty of Engineering. But he also is a professor in the Electrical and Computer Engineering Department. I will let him introduce himself about his research because he will be the more appropriate person to do so. Myself, I'm a business management background, but I've worked with engineering almost all my professional life so far. So in some universities, I'm considered a doctor in engineering. Others don't. That's fine. Thank you.
Thank you very much for the introduction. Welcome, everybody. I'm excited to present some information about the University of Alberta and our faculty. And the goal, of course, is in the end of this presentation, some details about the seed program which we established here. So University of Alberta, can you go back one slide? Oh, sorry. I just wanted to say that it's a really large university. We have more than 40,000 students. We have 70 plus faculties. All those buildings are part of the campus, starting with the University Hospital. The engineering buildings are on the top left here. And we are now part of a college, which is called College of Natural and Applied Sciences, as was mentioned. This is a recent development. We decided to somewhat put together multiple faculties which have some relations together. And we now have College of Natural and Applied Sciences. We have College of Health Sciences. We have College of Arts and Humanities. So those are the 3. I'm going to have to spend a little bit on the College of Natural and Applied Sciences, but I'm going to concentrate on the Faculty of Engineering. So the University of Alberta is ranked 5th in Canada and is within the top 100 of the most recent rankings, placed us somewhere in 80, depending on which ranking you do. Some of them are even better. So it's quite significant university doing very well in education and research of students across all the fields which I mentioned. We have more than 200 different undergraduate programs. Thank you. So we have more than 200 undergraduate programs. We have 500 different graduate programs. We have 3 colleges, as I mentioned, and 18 faculties. The College of Natural and Applied Sciences, which, as I mentioned, is our body which is putting together our faculty with 2 others. So we have 3 faculties specifically in addition to engineering, is the Faculty of Science and Faculty of Agricultural Life and Environmental Sciences. Within the college, there is more than 3,000 undergraduate students, about 3,500 graduate students. We have altogether 625 faculty members and growing, and the external funding per year is equal to about 200 million, all in Canadian dollars. If you look at the types of research at the college, again, we are really doing very comprehensive research, putting together all the fields of natural and applied sciences within the 3 faculties which I mentioned. If you look at the role of the college within the university, the college actually brings about 40% of the external research funding. So it's very significant. There is a lot of funding, a lot of interest, both from the funding agencies and from industry to work with engineer scientists and agricultural scientists as well. If you look at the strategic areas of the College of Natural and Applied Sciences, and I brought this up because I know that you have different programs and they may be interested in the future to go beyond what the Faculty of Engineering covers. So we cover the fields of energy, robotics and autonomous systems, quantum technology, AI and machine learning, nanotechnology. We have very good equipment for microfabrication. It's very unique across Canada. We are interested in different types of defense-related research, space and astrophysics. Given our location, some important topics are also related to the north and northern climates and also environments, bioresource engineering, agriculture and food systems, forest ecology and management will be last significant strategic research area within the college. It's quite a long list, but again, don't forget that this is representing all three faculties within the college. So in what remains, I'm going to concentrate on the Faculty of Engineering, which is my home faculty and where I serve as an Associate Dean for Research Operations. Similar figures what we saw before, but now scaled down a little bit. We have more than 220 faculty members and different support staff of technical and administrative nature. We have more than 4,800 undergraduate students, 1,600 graduate students. And if you look at some statistics, they are very good because 90% of our graduates from our programs are employed within 2 years of graduation. And in terms of where they apply, quite significant portion, 19% of alumni started companies or lead companies, which are somewhat related to environment, which is an important strategic area, both for the college and for the faculty, as you will see. The faculty itself has 5 departments. You will see that some of them are broader. They do not cover necessarily only one program, but we have Department of Biomedical Engineering. This is our youngest department, which is now led by the Faculty of Engineering. And we also have colleagues, of course, from medicine and different related fields. At this moment, they only offer graduate degrees. It's a master's degree in biomedical engineering. But of course, there is a lot of research going on as well. Chemical and Materials Engineering, with their School of Engineering Safety and Risk Management, is another department. And I'll provide more details on their programs and what type of research they do later on. The third one is Civil and Environmental Engineering, with the School of Mining and Petroleum Engineering. So again, quite broad range, really covering everything from construction to environment, water-related issues, to mining and petroleum. Electrical and Computer Engineering, which is my home department, is again bringing together electrical engineering from power systems, communications, etc., to computer engineering, both on software and hardware side. And we also have an engineering physics program, which is putting together some of the electrical engineering aspects with physics and other fields. And finally, we have mechanical engineering. As you will see later, mechanical engineering is also covering the subfield of industrial engineering. If you look at the undergraduate programs, of course, they follow what's in the name of the department, but pointing out few additional topics. So in chemical engineering, they offer program in chemical engineering, including computer process control option and well sense and elective. In civil engineering, there is civil, including environmental engineering option. In computer engineering, we have again a number of options. The basic one, software engineering option, which is very popular, probably elsewhere as well. And nanoscale system design option. In electrical engineering, again, we have the traditional electrical engineering plus the nano engineering option. In engineering physics, we have traditional and again, nano engineering option there. Then we have materials engineering, which is of course covered by the Department of Chemical and Materials Engineering, mechanical engineering, with biomedical engineering option, and mining engineering and petroleum engineering, which are housed, as we mentioned before, under the civil and environmental engineering umbrella. Programs are accredited by the Canadian Engineering Accreditation Board. which is important for our students so they can get accredited and they can perform appropriate roles in the industry. We also have a very strong undergraduate program in top form. So students extend their degree. The standard degree for Bachelor of Science in Engineering is 4 years. If students are successful in applying for the top program, their program will be extended by 1 year, and they will have guaranteed or supported by the university to find work for up to five work terms, duration of 4 months. In terms of graduate programs, we have a broad range of possibilities from Master of Engineering, which is course-based, through Master of Science, which is thesis-based, Doctor of Philosophy, traditional Ph.D. program, and we also have course-based Internet Networking Master of Science, which is offered jointly with the Department of Computer Science from our sister faculty. There is a number of areas, but I don't think that I necessarily have to go through all the details. All of those will be the subfields of each specialty area, as you can imagine, and of course we'll provide you with a copy of this so you can. We have a number of opportunities for enhanced learning by students, starting with this research award, which is traditional, very popular among students. They have opportunity to work in a research lab. They have a small reward per term stipend, which they will receive, and they really quite often gain very valuable and motivational experience in research, which in many cases leads them to apply later on for graduate studies. So it's a very good vehicle for us to attract students to our programs. We also annually hold the Faculty of Engineering Graduate Research Symposium, which is for graduate students and gives them really opportunity to share, to practice, to show to their peers and discuss the results of the research. And again, this is quite large event. In our conditions, we would have about 150 submissions of abstracts, which will be then presented, some in oral and some in poster form. And there is a number of student projects, so that this is another great opportunity for students to be able to participate in different types of projects. You know, Formula SAE, satellite program, there's already several satellites which were launched, developed by the students of the faculty, etc. We have good facilities to support both student learning and research. I mentioned Manopap already. It's an open access training center which provides collaboration, provides services to small and medium enterprises and other industry to satisfy their micro and nanoscale fabrication needs and characterization of devices. So it's really very unique. It's a facility which is well equipped and it's able to attract enough interest from the industry that they can grow and they can purchase more and more advanced devices to work with. We have also engineering garage, so it's a type of fab lab which we see around here. We have of course a large number of different tools, starting from 3D printers with different types of materials used, and then just the basic shop supplies and shop equipment, so students can work on their projects or projects for their classes. We have quite advanced high-performance computing facility, which is called Elsevier, standing for Industry Sandbox for AI and Computing. As you can hear from the title, it's primarily used to help small companies, small industry, to try out things with AI, but we have the opportunity and possibility to use it also with our students. So it's really enriching and giving us great access to computing power when we need it. Another major scale facility is Magnetic Resonance Research Center, which has very expensive, large MRI facility, full body MRI systems, which are 100% dedicated to research. It's very important. This is just an illustration picture from the Elko Engineering Garage. You can see some of the equipment in the background, and you can see a group of students unpacking some stuff. We really strive to work collaboratively, and we do it within the faculty, within the college, within the university, but also international, and we look forward to really start working with many of you here as well. If you look at some numbers again for the faculty itself in terms of research, we have more than $70,000 million annual research revenue. We have a number of industrial research chairs which are supported by the federal funding agency. We have a number of Canada research chairs, again, endowed chairs which are supported by the federal government, and other chairs which are sponsored by different consortia, industry, etc. And we have also few chairs supported by foundations. If you look at strategic research areas within the faculty, there are 5 of them. The first one is energy and minerals. This is really important. We just recently opened a new center for energy and mineral processing, which is funded by the industry from endowments. We have interest in resilient infrastructure. That will be everything from building to bridges to transmission infrastructure, pipelines, etc. Climate and environment in general. Biomedical engineering is coming in our conditions, and it's again one of the areas selected to be a strategic one. And finally, emerging and advanced technologies, which would again encompass quantum computing, AI, machine learning, and similar technologies under one umbrella. Now I would like to talk a little bit, basically just listing the areas which are covered in terms of research under the individual departments. In chemical and materials engineering, there are people looking at biochemical and biomedical engineering, metallurgy and mineral processing, as I mentioned, nano and functional materials, process systems and engineering, control and automation to get applied to industrial control, reaction and engineering, catalysis, safety and risk management. This is a separate sub-school within the department. Surface and interface science, and thermodynamics and fluid mechanics. So those will be under the department of chemical materials engineering. Of course, there will be a number of different application areas. Many of them would have something to do with carbon capture and storage, with hydrogen production, with absorbents, etc. In the Department of Civil and Environmental Engineering, this is actually our largest department, which was formed by emerging number of subfields. We cover everything from construction engineering, including construction management. We have environmental engineering, geotechnical engineering, mining engineering is part of this group, with petroleum and structural engineering, then transportation engineering, the roads and the smart cities in terms of the mobility, and finally, water research engineering, again, one of the areas which we jointly have a great interest in UTEC. In electrical and computer engineering, we have the biomedical engineering. A number of people are looking at diagnostics and MRI, for example, and at surgical robotics. I believe that there was actually one of our colleagues presenting a course recently for students in robotic surgery. Communications, 5G, 6G systems, computer engineering, control systems, including again robotics application, electromagnetics and microwaves, a lot of sensing applications, for example, and of course antennas for cellular services, similar devices. Energy system, this is quite large group, and I'm part of this group as well, looking at everything from the renewables to energy distribution, transmission, etc. We have a group looking at integrated circuits and systems. So this is mainly under the computer engineering umbrella, including the fabrication. And again, as I mentioned before, we have fabrication capacity as well, and we are part of other consortia allowing us to do fabrication of integrated circuits. In reality, microsystems and other devices, including different types of MEMS, etc. Photonics and plasmas. Again, quite significant group, looking at everything from sensing, quantum computing or quantum science applications all the way to nuclear fusion. Signal and image processing. software engineering and intelligent systems, and solid state electronics. So again, going back more to the hardware and devices for electronics. In mechanical engineering, there are groups looking at advanced manufacturing, energy systems, fluid mechanics, mechanics of materials, engineering management, as I mentioned, and also biomechanics. So quite a few people would be cross-appointed between mechanical engineering and biomedical engineering, which I mentioned before. We have a number of research institutes and centers on innovation. One which is going for about 4 years, it's called Autonomous Systems Initiative. And we have Canadian Center for Welding and Joining, Canadian Underground Infrastructure Innovation Center, so people who are engaged in drilling and laying down the structure on the ground. Center for Energy and Mineral Processing, which I mentioned, Construction and Innovation Center, Institute for Oil Sands Innovation, Oil Sands Tailings Research Facility, again, the mining issues, the Magnetic Resonance Research Center, which I mentioned before, and the Steel Center, looking at construction applications of steel. We have really a broad spectrum of industrial partners. It's very important for us, not only from the research perspective, but also for our students and for the industrial partners themselves. They can really see the value. The students are well prepared. Quite often students gain the experience working with the industry in their coursework or in their research project during their degrees, and then they are ready to join the industry and they are proficient right away. We have different types of activities through formal types, commercialization, patents, etc., or informal in terms of some collaborative research and consulting performed by our professors. And industry is really able and excited about accessing the research expertise which we have in the faculty. I believe this is one of the last slides looking at the number of journal articles which we've been publishing. So you can see that the annual production, there was a small dip in 2022, but typically it's well above 2,000 articles in refereed journals per year produced by our faculty members. So finally, I'm getting to the information about the seed fund program. But maybe I would stop here for a few minutes, just in case you have any questions related to the content so far, if you are interested in some more information and some specific programs.
I was interested in the Dean's research that you offer to undergrad students. What's the duration of the scholarship? So it's a scholarship that you provide?
It's not a scholarship, it's a one-time payment. So students, after they complete their projects and present, will get a reward of $500. So it's really one-time payment. So it's more or less based on a voluntary work. It's not very extensive. It's typically, I would say, maybe 100 hours per term. But it gives them the opportunity to work and share. And but it's not really scholarship or something. I can send you more information. But if not, let's go and let's have a look at some of the details of the UTEC-UAlberta seed fund program. And we are really excited about this possibility and opportunity, and we are looking forward to launch it. So this has been established to support collaboration between faculty members of our two institutions. So it's not student exchange necessarily, although there is a component of student exchange as well, student mobility. It's not just travel, but it's really conducting research together. So we can learn from each other, we can support each other, and we can achieve something in much more tangible terms, whether it's publications or industrial applications. Joint activities in research and publications are one of the goals. Mobility of faculty of students is another one. And last but not least is building capacity at UTEC in form of support for English as medium of instruction, so preparation or supporting further development of your professors teaching in English. In general, the funds be used for different types of activities encompassing research, such as exploratory research initiatives, planning workshops and meetings, some mobility of staff and students, and the salaries or stipends, I should say, for graduate students, which can maybe be depending on specific side of the partnership, but in our case, we typically fund our students in form of new stipends. The planned activities are spread over 3 years. So we will start this year. This will be year 1, 2023-24. And in the following 2 years, there will be similar activities. So what's specific for the first year is the capacity building, the training for English as medium instruction for 12 professors from UTEC. This already started and it's taking part partially online, virtually, and then there will be some in-person, face-to-face instruction next year. This year, we will also launch one grant, which will be to support joint research between faculty from UTEC and UAlberta, right? So we are looking for some ways how we can make the match, how we can introduce professors on either side to one another in the groups, so they can learn about each other and they can develop the proposal jointly. It's not independent writing and then matching later. It's really important that this will be done together. In addition, there will be mobility for one professor who will be the awardee and one student for about 12 days to enhance the collaboration activities within the research group, which will be awarded. In the following 2 years, the activities will be identical, so they will involve 2 grants in each year, so 2 grants 24-5 and 2 grants 25-6. They will be similar to what we will do as a kind of tryout in the first year, and they will be supporting the research between UTEC faculty and UAlberta faculty. Similarly to what we mentioned before, there will be some mobility components as part of this award. And in addition to that, there will be 5 visiting graduate students to carry out research under the research groups at UAlberta for minimum 3 months. So this is not directly connected, but it's again research activities for students to allow them to have the experience of conducting research with UAlberta professors. The intent is to have a competition for the seed grant program to really catalyze and support and further develop the international cooperation between our 2 schools. We will be interested in innovative research directions of common interest, so it's not delimited or specializing in some selected research areas. It's open to all areas of research. It's really about the merit, finding the match and being able to find a partner and develop jointly the project. The funds will be allocated. The funds will stay within the home institutions of participating researchers, so it will be quite simple in terms of the funding. The co-principal investigators, so the 2 leads, one from each side, will be required to report on the project outcomes. The 2 lead researchers will be also required to provide at the end of the 1-year grant period a report to their respective research offices within 2 months of concluding the projects. In terms of eligibility, each proposal must be developed jointly, and as I mentioned, they must include both lead investigator or co-principal investigator from UTEC and from UAlberta. And they must be the current academic staff or faculty members at their respective institutions. In addition to those 2 leads, there is a possibility, it's not a mandatory, but there is a possibility to involve other academic staff members from both sides. If appropriate, there could be other team members from institutions or industry partners. Again, this is not mandatory, but it's an option if it's for the benefit of the project. It will be really assessed individually. Each faculty member can apply only once in any given competition, right? And so if they were interested to apply as co, because they can do so, but as a lead applicant only once in each competition. If you look at the application process and tentative timelines, we will have a call for proposals and the dates will come immediately. You will already see them on the slide. The completed proposals will include application form, which we will release shortly, and the budget and budget justification, and some short simplified version of curriculum vitae for both lead PIs. So in terms of the timeline itself, looking at the current project year, we expect that the application process will open in September 1st. So at that time, all the details will be finalized, the forms will be finalized, and it will be set in stone, right? The rules. We will expect that in about 4 weeks, in the end of the 1 month period, October 1st, the application will be due to be submitted. Now, simultaneous submission to UAlberta and UTEC, and again, those details will be provided and will be part of the application form. November 15th, so in about 6 weeks, we will be able to announce the details. That's what we plan to do. We will have a joint committee formed by administrators and faculty members from both institutions. The start date will be December 1st of this year. It will last for 1 year, so November 31st will be the end date. And accordingly, the final report for each project or for the first year project will be at the end of January 2025. The selection process will be conducted by the joint evaluation committee, as I mentioned. Again, we will iron out all the details and they will be announced prior to the launch. So we will have the committee composed of people from both sides. The selection will be made by 3 members representing each institution, and we may solicit external reviews depending again on the situation. It will be a fair process in any case. The selection criteria will be based on objectives, how the objectives are set, and what's the scientific merit of the proposal, the project plan, the team, and sustainability. So there should be some plan how we can continue that. It shouldn't be just one-shot thing, 1 year thing, but it should be some intent expressed and described in the proposal, how we plan to continue, what we like to do after this 1 year project is over, how we hope to expand and continue this collaboration. So that's all for the description. As I said, most of this information is tentative, although we spent time to put it together, but there may still be some small changes here and there. And if you have any questions, I'll be happy to address them now.
I have a question. Yeah. In one of the slides, you mentioned that it had to be one faculty of engineering from Alberta, but you also mentioned that you're interested in enhancing this research across all this. So is it just faculty of engineering?
This is just faculty of engineering. Yes. So this agreement is based on the faculty of engineering. It's starting there, and I wanted to put the context. And for example, we mentioned that there could be other faculty members involved, but the leads have to be from the faculty of engineering. If it was, let's say, something related to biomedical engineering, we can even reach to our colleagues from the faculty of medicine. So it is a possibility that the lead is to be from engineering to Alberta.
Okay, and for example, there is also, I was reading through the manual, for example, the earth and atmospheric sciences. I'm assuming that there are some professors that work for this school, but they could be like adjunct professors for engineering. Does that apply or has to be just specifically engineering?
So it must be the own faculty members.
Okay.
It won't work, but there are people who work in related research, which are in engineering, so let's say the exploration.
What's your area of research?
I do fluid mechanics, but environmental fluid mechanics. So it can be from civil and environmental engineering.
Mechanical as well for us.
Mechanical could be as well.
It's very tricky because I help the students. How many of you have had students to ELAB? Do you know ELAB scholarships? Yeah. So I'm in charge of guiding them to get a professor, and sometimes civil student here ends up in mechanical at U of A, even at the School of Public Health. So it's very broad. So maybe if you're looking for something specific, you can send us an email. I'm going to be here and we can go and look together like the correct professor or maybe advise you where you should look for the information.
I don't know what's there. So now, are you monitoring the chat? Yeah, we're gonna have questions. I think it was very clear, and I think we're all looking forward to the opening. No?
We will inform you, of course, and the entire faculty and school about the details when they are fired out.
So,
yeah,
usually one of the things that we can use some industry partners in those. That means industry partners in Canada are involved.
Yeah.
Would be better. And so we thought we work on this program to be as flexible for you and also for us, because there are some maybe research projects that you would like to do that are linked to some issues here of some companies, but are similar to our issues in Canada. Like, I don't know, for instance, water, tailings for mining. Just so there is a common interest on both sides, and we have some of our professors working already with companies in Canada on tailings that have operations in Peru, for example. So it would be, it's very flexible. If there is a kind of we can join forces to attack some common issue in both parts of in both countries, that would be perfect.
Yeah. Besides this particular program, if one of our research faculty is interested in collaborating with a professor from the School of Engineering in Quebec, so can we contact them through you? Or
yeah,
is that a possibility? Okay.
Of course, a good overview of everybody is doing, so we can help. Specifically related to the C program, we plan to have some matchmaking sessions virtually to present what the interests are, and also learn what the public interests and expertise on the other side, so it's easier to find the partners. We will announce the details here, so we might make an announcement.
Yeah. So the route to ask the question could be directly to you, since you will be here, or through the office, outside research center. Okay? And also channel your queries.
So we're going to work first on a matchmaking session with the Office of your Research here. So our first work will be matchmaking sessions between professors. So I encourage you to look. I can send you more specific links based on the topics you're interested. So you can look at potential professors or collaborators at U of A. So then we can get like a more specific matchmaking sessions for both groups.
We have one question on the website. Is there any restrictions on the topic of the research proposal that are submitted? Should it be within the previously mentioned strategic research area?
No, it's not restricted to the strategic area. It can be any topic which is covered by the faculties.
This is very, very general. Yeah, so we can be very specific.
Yeah, but it's intentionally very general because we want people to work together. It's more important than to follow some, pre-lined strategic areas, and you may not be able to form a good relationship. So the relationship building can start in the collaboration efficient ways more.